In this video, we are going to kind of expand on yesterday's lesson. Yesterday we talked about perfect squares, and we talked about how to find out if a number was a perfect square or a square number. Today we're going to talk about the opposite of that, or imperfect squares. So for vocabulary, we've got an imperfect square is just a number whose square root is irrational. That means that the square root is equal to a decimal number. You'll recall that we did the example where we tried to make a perfect square with 5 square tiles. So we've got our 4 square tiles here, and the only way to add this 5th tile in would be to cut it up. But since I'm cutting up this last tile, that wouldn't be a perfect square. So today's lesson is about what to do when you have that extra few squares that won't fit into the current square to make it a square again. And first we're going to just kind of revisit rounding. In these first examples, we're going to round each number to the nearest 100th place. In the very front of your binders, there is a place value chart. The 100th place is the second one. In order to round to that place, you have to look at the number behind it. So we're going to look at the second number. That's our important number. That's where we're going to stop eventually. To decide what to do there, we look at the number behind it. If that number is 5 or more, we add 1. If that number here is 4 or less, we just stay. 6 falls in the 5 or more category, so we add 1. So rounding this would be 9.3, and we're going to add 1 to the 8. 8 plus 1 is 9. The 100th place is the second digit behind the decimal. We look at the number behind that to decide whether we should round up or stay the same. The number behind it is a 2. 2 falls in the 4 or less. So we're going to just stop at the 6, and we're not going to add anything to it. It'll just stay 2.56. In the number negative 3.87836, we want to round to the 7. So we look at the place behind the 100th place. That's 8, which is 5 or more. So we need to add 1 to the 7, the thing that we started with. 7 plus 1 is 8, so we'll have a negative 3.88. And the number 1.2683, we're rounding to the 100th place, which is the 6. So we'll look behind the 6 at the 8. 8 falls into 5 or more, so I have to add 1 to that thing that I started at, the 6. 6 plus 1 is 7, so instead of 1.26, I have 1.27. Next we have negative 6.5962. I'm rounding to the 9, the 100th place, so I look behind it. 6 falls in the 5 or more category. So we have to add 1 to the 9. Adding 1 to 9 really makes that 10. So there's going to be a 0 in the 100th spot. But I'm adding 1 more now to the 5 spot, or to the spot with a 5 in it, the 10th spot. So this is negative 6.6. We're going to keep the 0 there because we rounded here. So we're going to keep that 100th place value there, even though it would be the same value if we didn't have the 0. Now we're looking at negative 9.796. The hundredths place has a 9 in it. So we look one behind the hundredths place. That's a 6. 6 falls into 5 or more. So I'm adding 1 to 9. Well, 9 plus 1 makes 10. And again, we see that there's going to be a 0 in the hundredths spot. And now I'm combining 1 and 7 in the tenths spot. So this is negative 9.80. The second box asks us to round each number to the nearest tenth place. The tenth place is the first decimal spot. So when I round to the first decimal spot, I look at the number right behind it, which would be in the hundredths spot. I'm looking at the number directly behind the decimal in the tenth spot. To decide if I should go up or stay the same, I look at the number right behind it. 5 falls into 5 or more, so I need to add 1 here. I'm adding 1 to 9, which would make this 10. The 0 is going to be in the 10th spot, and for the 1 spot, I'm combining a 0 and a 1. So we have 11.0. My next 10th spot is a 5, and directly behind the 5 is a 5. 5 falls into 5 or more, so I'm going to add 1 to the 5, and that makes it a 6. So now we have negative 38.6. Looking at the next 10th spot, that's a 9. Look behind it to decide how to round. Behind that 9 is a 9. 9 falls into 5 or more, so I'm going to cross that out and add 1 to it. 9 plus 1 is 10. So the 0 goes here and the 1 goes to the left. Now we see that there's a 0 in the 10th spot, but now I'm combining 1 and 7 in the 1 spot. 1 and 7 makes 8. There's a decimal and there's a 0. Looking at the 10th spot, that's a 3. Directly behind it is a 3, which is 4 or less. So we're just going to keep the 3 all by itself, or just the same. So this is negative 5.3. Looking at the next 10th spot, that is a 9. Look right behind it to see how to round. Right behind it is a 2. 2 is 4 or less, so it's going to stay as a 9. I keep that as a 9. So now I have 9.9. In that last rounding example, the 10th spot is a 5. Look behind the 5 and we see a 3. 3 is 4 or less, so I keep the 5 as is. So I have negative 17.5. It stays the same. That's all for rounding. Now that we're experts on rounding, let's look at some imperfect squares. This says to use the number line to estimate the side length of the squares and square root of the imperfect squares. Round to the nearest hundredth. This first square has an area of 12. We know from yesterday that if we take the square root of the area, we'll find the side length. So we want to take the square root of 12. But the square root of 12 isn't perfect. I can't make a perfect square using 12. We do know, though, that 12 is between 9 and 16. So I know that the side length is between the square root of 9 and 16. So we're going to look at our number line. The square root of 9 is 3, and the square root of 16 is 4. So we know that the side length is between 3 and 4. "12 is closer to 9 than it is to 16. So whatever our answer is, it's going to be closer to 3. So it'll be less than 3.5. This is where we'll use our calculators. I'm actually going to go get mine so I can show you guys how to do this on a TI-83 or TI-84. Okay. Here I have a TI-83. Normally in class we use TI-84s. Some of you have a TI-83 on your desk. The only difference, the major difference here, is that on an 83, the second button is yellow. To type in a square root, you're going to hit the second key, followed by x squared. You'll see that it has a square root symbol right above it. Once you've done that, you get a square root symbol on your calculator. We want the square root of 12, so in that square root, we're going to type in 12. Now this has some open parentheses. We're going to close those off. We're going to hit enter. We see that it's about 3.464, and that keeps going on forever. 3.464. Let's round to the nearest tenth. If I'm rounding to the nearest tenth, that's the 4 spot. So we look at the 6. 6 is 5 or more, which means instead of 4, we're going to have 4 plus 1, which is 5. So we're going to say that the side length is roughly 3.5. This symbol means almost equal to. It means about. The side length is about 3.5. That's a really pretty close guess that we had. We said that the square root of 12 had to be between 3 and 4. We said it was closer to 3, which it was, because it was 3.4. So this is a really good guesstimate using this method of finding where we fall on the number line. In the next example, we have this an area of 108. To find the side length when we know the area is 108, we take the square root of the area. The square root of this area is the square root of 108. 108 is between 100 and 121. So I know that the square root of 108 is between whatever the square root of 100 is and whatever the square root of 121 is. The square root of 100 is 10, because 10 times 10 is 100, and I wrote that over 81. The square root of 100 is 10, because 10 times 10 is 100. And the square root of 121 is 11, because 11 times 11 is 121. 108 is way closer to 10 than it is to 11. So I'm going to say this is probably, it's definitely less than 10.5, maybe even 10.3. So we're going to check on our calculator now. We know that this is between 10 and 11. And it's way closer to 10. So we're typing in the square root button by hitting second x squared. And we want the square root of 108, which is 10.39. About 10.39. 10.39230. And we'll round to the hundredths place this time. The hundredths place is the second place value. So we look behind that place value, which is a 2. 2 is 4 or less, so this 9 will just stay as a 9. So 10.39, and we're not going to write the rest of it. So the side length in this square is almost equal to, or about, 10.39. The next square that we want to find the side length for has an area of 218 units squared. When you know the area and you want the side length, you just take the square root of the area. The square root of this area would be the square root of 218. This only works for squares. The square root of 218 falls between 196 and 225, because 218 is between 196 and 225. Well, the square root of 196 is 14. This, because 14 times 14 is 196. The square root of 225 is 15, because 15 times 15 is 225. So I know that the square root of this number, 218, is between 14 and 15. $218 is a lot closer to 225 than it is 14. So I'm going to say we're closer to 15. And now we'll guess it's going to have to be maybe bigger than 3.5. So it's way closer to this, but not by an insane number. Maybe 3.6 or 14.6 or 14.7. I don't know where I got 3 from. Let's use our calculators now to check. Second x squared makes the square root symbol pop up. We want the square root of 218. Close it off. We get 14.7648, blah, blah, blah. 14.768, and that keeps going. Let's round to the nearest tenth. Tenth is the first spot, so we'll look at the number behind it. 6 is 5 or more, so we have to add 1 to the 7. Adding 1 to 7 makes that an 8. So this is going to be 14.8. The side length is almost equal to, or about, 14.8 in that square. Our last side length is from the square that has an area of 62 units squared. If you know the area to find the side length, you just square root the area in a square. That only works in a square. So we want the square root of the area 62. 62 is between 49 and 64. The square root of 49 is 7, and the square root of 64 is 8. So I know that the square root of 62 is between 7 and 8. 62 is a lot closer to 64 than it is to 49. So I know that we're closer to 8 than we are to 7. Let's think about how close that would be. It's definitely bigger than 7.5, maybe 7.9 or 7.8 and some change. So let's take out our calculator and see how close we got. Second x squared, then we're going to type in 62. We have 7.87, almost 7.9. So 7.874, and that keeps going. Let's round to the nearest thousandths place now. This is tenths, hundredths, thousandths. So we're rounding to that 4 by looking behind at the 0. 0 falls in 4 or less, so we're going to keep the 4 as is. So this will be 7.874. Next, we want the square root of 46. 46 is between 36 and 49. So the square root of 46 is between the square root of 36 and the square root of 49. So the square root of 36 is 6, because 6 times 6 is 36. And 46 is closer to 49. So the square root of 46 we know is between 6 and 7. And it's a little closer to 7. I'm going to say maybe we're at 6.6. So So we'll do second x squared to get the square root symbol on our calculator. We want the square root of 46. We have 6.78232 and more. That is 6.7823 and it keeps going. Let's round now to the tenths place. Looking behind at the 8. 8 is 5 or more. So we add 1 to the 7, which makes this 8. So the square root of 46 is roughly 6.8. Looking at the square root of 2, well, the square root of 2 is between the square root of 1 and the square root of 4, because 2 is between 1 and 4. The square root of 4 is 2, because 2 times 2 is 4. The square root of 1 is 1, because 1 times 1 is 1. And 2 is a lot closer to 1. I know that the square root of 2 is between the square root of 1 and the square root of 4. The square root of 2 is between 1 and 2. Two is a lot closer to 1 than it is to 4, so the square root of 2 is closer to 1. Maybe 1.1. Way smaller than 1.5, right? So we've got second x squared. We want to type a 2 into the square root symbol. And we get that the square root of 2 is about 1.4142, and it keeps going forever. That's an irrational decimal. Let's round to the 100th spot. When we round to the 100th spot, we look at the place right behind it. That's a 4. That's less than 5, so we're going to just keep the 1 as is. So we have 1.41. The square root of 2 is roughly 1.41. This was page 103 on the front for your binder. Imperfect squares, remember, are irrational, which just means that they are non-terminating and non-repeating. You guys usually do pretty good with imperfect squares. I think your biggest problem on today's assignment will be rounding, so please refer back to this before you make your final answers. Again, your homework today is front and back. That's just because we gave you guys quite a bit of room to work things out. I don't think it will take you too long. If you have questions about the homework or any content in this video, please feel free to reach out and send me a message on Schoology, send me an email, or drop a comment on this video, and I will get back to you as soon as I can.